For this experiment, you will use items from your kit and distilled water. To prepare the sodium hydroxide solution, use your graduated cylinder to measure 75 milliliters of distilled water. Pour the distilled water into the Erlenmeyer flask. Put some gloves on. Use a weigh boat and the tare function on your balance to weigh out 0.3 grams of solid sodium hydroxide. Add all the sodium hydroxide to the flask. Stir the solution in the flask until all the sodium hydroxide is completely dissolved. Next, you will standardize this sodium hydroxide solution. Wash and dry the weighing boat and stirring rod. Weigh out exactly 0.16 grams of anhydrous citric acid and put it in the 250 milliliter beaker. Use the graduated cylinder to add exactly 100 milliliters of distilled water to the citric acid. Stir the solution with a clean stirring rod. Once the citric acid is completely dissolved, use the graduated cylinder to measure 20 milliliters of the citric acid solution. Pour it into your clean 100 milliliter beaker. Make sure to record the exact volume. Add 2 drops of phenolphthalein to the citric acid solution and swirl to mix. Fill the 10 milliliter graduated cylinder exactly to the 10 milliliter mark with your sodium hydroxide solution and record this as initial graduated cylinder volume. You will now perform the titration by using a clean pipette dropper to transfer the sodium hydroxide solution from the 10 milliliter graduated cylinder to the citric acid solution in the 100 milliliter beaker. You will add the sodium hydroxide a few drops at a time. As you titrate, gently swirl the beaker to mix the solution. As you add the NaOH, you will see a pink color appear and disappear as you swirl. As you continue to add sodium hydroxide, the pink color takes a longer time to disappear. This means you are approaching the endpoint of the titration. Add just 1 drop of sodium hydroxide at a time. This solution looks almost colorless but is faintly pink. Placing the beaker on a piece of paper will help you see the color of the solution. When you have reached the endpoint, return any unused sodium hydroxide solution in the pipette to the 10 milliliter graduated cylinder. Record the amount of sodium hydroxide solution in the 10 milliliter graduated cylinder as final graduated cylinder volume. This is the titrated citric acid solution. This is the solution 1 drop past the endpoint. Just 2 or 3 drops past the endpoint will make the solution a saturated hot pink. Dispose of the pink titration solution in the sink with water and rinse the beaker with distilled water. Do not waste any of the sodium hydroxide solution. Fill the 10 milliliter graduated cylinder back up to 10 milliliters and use it to perform 2 more titrations of the citric acid solution. You should now have the data to calculate the concentration of the sodium hydroxide solution from each trial and the average concentration of all 3 trials. Now you will perform another set of titrations to determine the percent citric acid in an unknown impure sample. You must use the sodium hydroxide that you standardized, so set the sodium hydroxide solution in the 250 milliliter Erlenmeyer flask to the side. Pour the remaining citric acid solution down the drain with plenty of water, and make sure both the 100 milliliter and 250 milliliter beaker are clean and dry. Weigh out 0.18 grams of the unknown. Transfer the unknown to the clean, dry 250 milliliter beaker. Use the graduated cylinder to add 100 milliliters of distilled water to the unknown. Stir well with a clean stirring rod. This is your unknown impure citric acid solution. You will use the same steps to titrate the impure citric acid solution as you did for the anhydrous citric acid solution. Once you have performed 3 titration trials, you will be able to calculate the percent citric acid in your unknown sample from each trial average percent of citric acid of all 3 trials. Rinse all solutions down the sink with lots of water, dispose of the plastic pipettes, wash your equipment with soap and water, and clean your work area.